Muscle contraction begins with an action potential sent down the neuron into the synaptic end bulb. From there, the charge from the action potential builds up until it opens up the voltage gate channel, which allows calcium ions into the synaptic end bulb. The presence of the calcium ions releases acetylcholine through exocytosis into the synaptic cleft of the neuromuscular junction. The acetylcholine floats around until it finds receptors to bind to. It binds to these receptors in the ligand gates, which opens up a channel, allowing the sodium ions to pass through to the other side of the sarcolemma. Once the positive charge from the sodium ions builds up and gets to a certain point, it allows for a voltage gate to open up and an action potential to travel through the sarcolemma into the T-tubule and down into the muscle. That action potential travels until it reaches another voltage gate at the SR, the sarcoplasmic reticulum, and once it builds up there, it opens up the voltage gate, depolarizing the membrane and allowing the release of calcium into the sarcoplasm. That calcium floats around until it can find a troponin to bind to. Binding to the troponin allows the troponin to move the tropomyosin out of the way of the myosin binding sites, and myosin heads can bind to actin. Now, for myosin to bind to actin, ATP is involved. When ATP is bound to the myosin head, it causes the head to cock. Hydrolysis happens. That bond with the third phosphate breaks, turns into ADP. When it turns into ADP, it causes the myosin to be able to reach up and grab onto the actin. The ADP falls off. The myosin head keeps pulling on the actin until another ATP comes along. It likes ATP better, grabs that ATP, lets go of the actin, recocks its head. The ATP hydrolyzes again. Turns into ADP, reaches up, grabs onto the next binding site. The ADP falls off, it keeps pulling, and it continues that cycle over and over again, shortening the sarcomere until something makes the contraction stop. Now, for the contraction to stop, the action potential has to stop. When the action potential stops, there's not enough charge here to open the voltage gate, so calcium can't come in and it can't cause the release of acetylcholine. Without acetylcholine, there's nothing to bind to ligand gate receptors. Sodium can't go into past the sarcolemma. There's not an overall charge on this side of the membrane, so the second voltage gate does not open, and the action potential is not released on the sarcolemma into the T-tubule. Without that action potential, the voltage gate in the SR doesn't open, and calcium is not released into the sarcoplasm. Without the sarcoplasm, there's nothing to bind to the troponin, which means that it does not move the tropomyosin out of the way of the myosin, and myosin cannot bind to actin. Now, to remove the acetylcholine from the synapse, there's 3 different options. 1, you can just let the acetylcholine diffuse out. 2, it can be taken back up into the synaptic end bulb. Or 3, an enzyme called acetylcholine esterase comes through and just breaks up the extra acetylcholine. To get rid of the sodium ions, there is a sodium-potassium pump that pumps it out back into the synaptic cleft here. And without the charge from the sodium, there's an overall charge here, which means that the voltage gate, the second one, does not open. There's no action potential. Without the action potential, there's nothing to open up the third voltage gate. And without that one being open, the way for the calcium to come out is closed and no more calcium is released. And the extra calcium is taken out by calcium active transport pumps. And without the calcium, the troponin moves back in the way of the myosin, so it can't bind to the actin. And the myosin the myofilaments slide apart. Now, there are disorders that can affect the muscle fiber. One of them is called botulism. It's caused by Clostridium botulinum. It blocks the release of acetylcholine, and without acetylcholine, there's nothing to bind to ligand receptors. Sodium can't come through. There's no overall positive charge here. The second voltage gate doesn't open, so its action potential is not sent down the sarcolemma into the T-tubule. Without the action potential, there's no charge to open up the third voltage gate, and calcium is not released from the SR. Without the calcium, troponin isn't binding to anything and doesn't move the tropomyosin out of the way of the myosin head's binding sites, and so muscle contraction doesn't happen.